Welcome back as we continue with voltage measurement procedures. The signal generator is set to generate an AC sine wave. To prepare the scope to read a peak-to-peak voltage, switch the input coupling switch to ground and superimpose the trace on the horizontal center line using the vertical position control. Switch the input coupling to the AC position and adjust the volts per division control so that the entire waveform fills the screen. Switch the coupling switch to DC and observe the waveform. Notice that the waveform remains symmetrically about the horizontal center line. This tells us that the waveform is an AC voltage with no offset or DC component. There are a number of ways to express the amplitude of this AC voltage. We'll start with the peak-to-peak value. Adjust the time per division control to display 2 to 3 cycles of the waveform. Adjust the vertical position control to position the negative peak of the sine wave on a convenient horizontal graticule line. Adjust the horizontal position control so that the vertical center line of the graticule passes through one of the positive peaks nearest the center line. Now count the number of divisions and subdivisions between the negative and positive peaks of the sine wave. To calculate the peak-to-peak amplitude, multiply the setting on the volts per division control by the number of divisions counted. The calculation is 4 divisions times 0,5 volts per division equals 2 volts peak-to-peak. It is sometimes necessary to express the voltage of a sine wave as a peak-only value. This is done by dividing the peak-to-peak value by 2. This means that the peak value will be half the amplitude of the peak-to-peak voltage. Usually, a sine wave is symmetrical, which allows us to divide the peak-to-peak value by 2, or measure the amplitude of either the positive or negative peak to establish the peak value. In this example, the peak value is 1 volt. An AC voltage is often expressed as an RMS, or root mean square value. To calculate the RMS value, multiply the peak value of the sine wave by the mathematically derived conversion factor of 1 over the square root of 2, or 0,707. This simply means that the RMS value is 70,7% of the peak value. The calculation is 0,707 times 1, which equals 0,707 volts RMS. Note that the RMS value of the AC voltage is equivalent to a DC voltage, which will produce the same heating effect. Finally, the average value of the AC voltage is calculated as 63,7% of the peak value. The calculation is 0,637 times 1, which equals 0,637 volts. This value, although useful to know, is seldom required. The RMS value is the most significant measurement of circuit analysis and performance. We will conclude this section of the program by examining an AC voltage that has both an AC and a DC component. In preparation, switch the input coupling switch to ground and superimpose the trace on the horizontal center line of the graticule. Set the input coupling switch to AC and adjust the volts per division control so that the waveform fills the screen. Now switch the input coupling switch to DC and observe the waveform. Notice that it has shifted upwards and off the screen. Bring the waveform back into view by adjusting the volts per division control. It is good engineering practice to always check for a DC component when measuring an AC voltage to ensure that the AC voltage is not resting on a DC pedestal. After the break, we'll discuss the measurement of time and frequency as applied to AC and DC waveforms.